This is an introduction to strings and manipulating strings. A string in MATLAB consists of any number of valid characters and is contained inside of single quotation marks. It's important to understand that strings are just vectors in which every element is a single character. The characters can include any valid character in the computer's character set. So that could include letters of the alphabet, both upper and lower case, digits, punctuation marks, white space, control characters. White space characters include things like the space, the tab, new line, carriage return, and so forth. And control characters are characters that you can't actually see, they can't print, but they do something. They accomplish a task, such as a backspace. You can have leading blanks, which are blank spaces at the beginning of a string, and you can have trailing blanks, which are blank spaces at the end of a string. Some other terminology, we say that a substring is a subset or a part of a string. And you can have an empty string, which is a string that doesn't have anything inside of it, so it has a length of 0. It would be two single quotation marks with nothing inside. So again, that's two single quotes with nothing inside, and that's called the empty string. There are several ways that you can create string variables. We can create string variables using assignment statements. So for example, I could say my string gets the value of, and then the string hello. Or we could prompt the user and read in a string. Don't forget that when you do that, you have to have the second argument to the input function, which is quote squote, which is how you specify that you're expecting string input. So for example, I could say my word gets the value of input, enter a word, that's my prompt, and the quote squote says that it's string input. That would show the prompt, enter a word, and then if I typed, for example, howdy, it would store in the string variable my word, the string howdy. Notice that when MATLAB displays the string, it doesn't show the quotes, but when you enter a string, you have to put quotes around it. Since strings are just vectors of characters, you can use a lot of built-in functions and operators that we've already seen. With numbers, they also work with strings. For example, you can use the length function to get the length of the string, since it is, after all, just a vector. And since it is a vector, you could transpose it, so that would get a vertical string. You can also index into a string variable to get individual characters or to get subsets of strings, or in other words, substrings. There are several ways that you can concatenate or join strings together. To horizontally concatenate strings means you're going to create one long string. And there are a couple of methods that we can use. One is we could simply put the strings inside of square brackets, as we've seen with numbers, variables, and expressions. That will concatenate them. So for example, if I put inside of square brackets two strings, hello and there, it creates one long string, hello there. And notice it doesn't put any space in between. It's just all of the characters of the first string immediately followed by all of the characters of the second string. The other way that I could accomplish that is using the strcat function. There are a lot of functions that manipulate strings that start with str, so it's easier to pronounce that as string even though it's str. So the stringcat function is the string concatenation function. It will concatenate strings together. So for example, if I say strcat or stringcat hello there, it will create the one long string with both of those strings concatenated together. Now there is a difference between using the square brackets to concatenate and using the stringcat function to concatenate. If there are leading blanks, using the square brackets will retain those blank spaces, whereas using the stringcat function will not retain the leading blanks. You can also vertically concatenate strings. So basically what you're doing is creating a column vector of strings. So what that really means is a character matrix, a matrix in which every element is a single character. There are two ways of doing this. Again, we can use the square brackets and separate with semicolons, just as we saw with number matrices. And we can use the char function. It's important to remember that we're creating a matrix, and since all rows in a matrix must always have the same number of values, that means with a string matrix, all rows must have the same number of characters. So that means that when you create the matrix, the shorter strings have to be padded with extra blank spaces at the end so that all the strings end up being the same length. The built-in function char will do that for you automatically. Let's look at some examples of that. So again, both the square brackets and the char function can be used to create a matrix in which every row has a string. So for example, I'm creating a character matrix called CMate. Using square brackets, I'm creating 3 rows in the matrix that have the strings hello, hi, and ciao. Now notice that since the longest string has 5 characters, that means I have to have 5 characters in all of the strings. So hello is going to have 5 characters. Hi, I have to make that hi and then space, space, space. So it's 5 characters altogether. And then ciao, it's 4 characters and then a blank space, so that all of the strings have the same length. With the char function, on the other hand, MATLAB will do that for you automatically. So you can just pass the strings hello, hi, and ciao without concatenating, or without rather adding extra blanks at the end. So both of those methods will create a matrix called CMate, which is a 3 by 5 matrix. Again, every individual element is a single character. So some of the shorter strings are padded with extra blanks. So for example, the second row is hi, space, space, space. There are a lot of string functions that we can use. There are some functions that deal with blank spaces. First of all, you can create a string of all blank spaces using the function called blanks. For example, blanks in parentheses 3 would create a string of 3 blank spaces. One of the uses of that is transposing a string of all blanks. In output, that would give you that many blank lines. So if you wanted 5 blank lines, for example, you could print blanks of 5 transposed, and that would print 5 blank lines. There are also functions that get rid of blanks. dblank removes trailing blanks at the end of a string. The function strtrim or string trim, that removes both leading and trailing blanks, but there aren't any functions that remove blanks in the middle of a string. There are also string functions that convert the case for letters of the alphabet. The upper function will convert all of the characters within a string that are letters to uppercase letters, and the lower function will convert all of the characters in a string that are letters to lowercase letters. A really useful function that works with strings is called sprintf. Now, sprintf works exactly like fprintf. We can call it in exactly the same ways, but instead of printing, what it does is it creates a string. So what you can do is you can use that to create a string that is customized by formatting it. Then, once you've created your customized string using sprintf, you can pass it to other functions that expect a string as input. So for example, a title on a plot, or the labels on the axes on a plot, or the input function that expects a string as a prompt. Here's an example. I create a random integer in the range from 1 to 50 and store that in a variable maxran. And then I use sprintf to create a string that says enter an integer from 1 to, and then the value of maxran fills in for the %d. So again, notice that's not printing. What that's doing is creating a string which I'm storing in a variable that I called prompt. And then in the input function, I'm passing that variable prompt. So the prompt shows up, enter an integer from 1 to, in this case 46 was the random integer. And I type in a value for the variable mynum. So anytime a string is required as input into any function, again, for example, title or input or xlabel, you can use sprintf to create a customized string.